Delve deeper into LWC lifecycle hooks with disconnected callback, rendered callback, and error callback for robust and efficient component management. Welcome everyone. In today's session, we are going to talk about understanding component lifecycle hooks. This is part 2. So without wasting any time further, let's proceed with the video. So first of all, let's talk about LWC lifecycle. We have already discussed about LWC lifecycle and lifecycle hooks. Today we will talk about those lifecycle hooks. So in the component creation, basically two lifecycle hooks are called. First is constructor and then connected callback. In the previous video, we have already talked about connected callback. If you haven't watched that video yet, you can click on the top right corner right now and go and see that video. After component creation, then the rendering phase comes and where rendered callback lifecycle hooks come to picture. Then interaction and updates goes on, and during that interaction and updates, if any DOM element gets updated, rendered callback gets called. That means frequently re-rendering takes place. And finally, destruction phase comes where disconnected callback occurs. Now this is one of the lifecycle hook whose output I am not able to show you. Now let's talk about rendered callback. As I said, rendered callback is basically invoked when rendering takes place. So it invoked every time a component is rendered. It is called after the component's DOM is updated and inserted in the DOM tree. Once all the DOM elements is inserted into the tree in the DOM tree, then rendered callback is called. Even if there is any change made, if there is any kind of update in the DOM element, then also rendered callback get called. Now when to use it? Whenever you want to perform actions that require the DOM to be fully available. So when to use it? Whenever you want to perform actions that require the DOM to be fully available. For example, if you want to manipulate elements or if you want to initialize third-party libraries, in those situations you should use rendered callback. So long thing short, whenever you want to work or manipulate the DOM elements, you should use render callback because in connected callback, DOM elements are not available. Now a key note for you, you should avoid infinite loops caused by setting properties that trigger re-rendering. So there can be a situation where changing a property can trigger re-rendering and that can end up to an infinite loop. Now the syntax of rendered callback is very simple. Just like connected callback, you create the method rendered callback and you put the logic inside it. You can see the example here. I am printing rendered callback invoked. So now let's check out rendered callback practically. So guys, here we are on our VS Code and you can clearly see I am still on the same previous lifecycle hooks LWC which I created in the previous video where we talked about connected callback. So just below that connected callback lifecycle hook, I created a rendered callback lifecycle hook and there I printed rendered callback invoked. Now let me just deploy this and check it out in the org. So I'm right clicking on deploy this source to org. Once everything is deployed successfully, let me take you to the org. Now on the org itself, just right click over here and click on empty cache and hard reload. Just to remind you, this option, right clicking on refresh button, will only be available if the inspect window is open. If the inspect window is not open, then you cannot right click over here. So I'm right clicking and clicking on empty cache and hard reload. And just focus on the console. Here you can see that after connected callback invoked, it is printing rendered callback invoked. Now let's see why you should use rendered callback rather than connected callback to manipulate any DOM element. Okay guys, so here I have implemented some more changes. In the HTML part, if you see, I am creating an H1 element, right? So here what I am doing is inside the connected callback, I am taking the reference of that H1. That is very simple by using the template. This is frequently being used in LWC. Now I'm going to explain you about this query selector later down the line, but you can understand it to be similar kind of method that we use in HTML, like get element by ID or get element by name. So here in the query selector, I am specifying H1 and this whole statement, this .template.query selector will take the reference of this H1 element inside this element. Then after, I am changing the color to blue. Now I am putting this statement outside the if else, okay, and making the if else as a comment for now. Now after changing the color, I am printing in connected callback after change, right? So now let me quickly deploy this and take you to the org. Now just right click over here, click on empty cache and hard reload, and you can see an error over here. It is clearly saying cannot read properties of null. It is saying we cannot read property from any element which is null. The property that is trying to read is style. So let's see our code where we are accessing style property. So here in our code you can see you are accessing style on the element, and here style is inaccessible because element is turned out to be null. And the reason why element is turning out to be null is because in connected callback most of the DOM elements are not created. If I use the same statement here in rendered callback, and here if I print it in rendered callback after change, save it, redeploy, go back to the org, right click and empty cache and hard reload. And this time if you see, because I use the DOM element inside the rendered callback, it is changing the color to blue. So that's what I was saying. DOM element or any kind of element that you are implementing in your HTML page is fully available in rendered callback method and not in connected callback. And if you will try to do so, it will create an issue for you. Now let me tell you one interesting thing. Here in the code, what I did is I added one count variable and assigned it with 1. And here in the rendered callback, I am incrementing the value of count every time. I am also doing one more thing. This specific statement which is assigning the value to this dot message, I am adding it over here and including the value of count in front of it. Now because of this, what will happen when the DOM element will be rendered, it will come here, it will change the value of message and change the value of count. Because of that, there will be a change in the DOM and it will re-render, and again rendered callback will call and it will change the value of message. This will keep on going on as an infinite loop. I will also make sure that the initial value of message will also be removed from the connected callback. So let me redeploy it. Let me be back to the org, right click here, empty cache and hard reload. And here you can see an infinite loop. Now to overcome that, what you can do is, let me just close this because I won't be able to stop it. So that's why I opened another tab. Let me close the previous tab itself. Here I will go to first tab page, but before that, here I have to overcome this scenario. Now to overcome that, what I will do is I will take help of a flag. I will create a rendered variable and make it false. And here I will make sure that if this dot rendered is equals to false, then only it should change the value of message and count, otherwise it shouldn't. Also inside here I will make this dot rendered is equals to true. So this will make sure that I change this value only once and not after that, because next time when it will come and check this criteria, this will become false because rendered flag has already become true. Now if I will deploy this, come back to my page, open the console, right click and empty cache and hard reload. So you can clearly see it is only being called once, and here it is having 1 over here. So that's how rendered callback can end up to an infinite loop, and that's how you can overcome it. Now some use case of DOM manipulation in rendered callback. So suppose we want to highlight a DOM element dynamically after rendering. In that scenario we can certainly use it. So in that scenario, this is the similar type of code that I have used right now, where I am changing the color of a specific h1 element to blue, and the output of it will change the h1 element text to appear in blue. So the constructor lifecycle hook is called before the component is added to the DOM. That means before connected callback itself. So the purpose of it is to initialize properties or set up default values. An example of it is like that. I have already told you about constructors when I was telling you about classes and objects in JavaScript. Similarly, the constructor over here will also be named as constructor itself. We are calling super keyword, or the super call is being made, which is to be made first, because here our LWC is having a parent class which is lightning element. So this super should invoke the constructor of the parent class first. So before you write down anything inside your constructor, you should invoke the super first in your LWC. Now let me show you how a constructor lifecycle hook looks like. So here you see I am back to my same lifecycle hook LWC, and I have added a constructor over here with a super call as the first call, and then I added any of my logic. If I remove this super and try to deploy it, see what happens. So clearly you see it won't show any issue in the deployment, but let's see what happens when we see that in the org. So here we are in the org. Let me right click over here, click on empty cache and hard reload, and here you will find an error. Now this is a component error. It is saying that must call super constructor in the derived class before accessing this. So here in the derived class, which is our own LWC, I removed this super, and that is causing the issue. So if I will add this super, save it and redeploy, then here in the org, if I right click and empty cache and hard reload now, the component will get loaded successfully and even the constructor lifecycle hook will get called. Here if you'll see, constructor invoked is first, then the connected callback is invoked, and then finally rendered callback is invoked. And rendered callback is invoked twice because of the change we made over there. Disconnected callback lifecycle hook, it is invoked when the component is removed from the DOM itself. It cleans up the resources like event listeners or intervals. An example of it is disconnected callback over here, where you can see I am printing component removed from the DOM. It is basically used to clean up resources, like whenever we are adding event listeners in the connected callback, then definitely in disconnected callback we should remove it. Error callback lifecycle hook. Now it is invoked or triggered if an error occurs during component's lifecycle. Its purpose is to handle errors gracefully and avoid breaking the app. Error callback looks something like this, and it is having two parameters like error and stack, which have the information about the error and the stack trace. Best practices for lifecycle hook. So use hooks judiciously, avoid placing heavy logic in the hooks, make hooks lightweighted. Avoid infinite loops, so when you are working with rendered callback, make sure you don't end up in the trap of infinite loop. I have shown you the example how you can overcome it. Clean up in disconnected callback, so in case if you have added any event listeners, intervals or any external resources in the connected callback, make sure to clean them up in the disconnected callback. Use error callback for debugging, so always log errors to troubleshoot issues efficiently. Now guys, that marks the end of this session. See you soon in the next session. Till then, thank you and take care.